السلام عليكم يا جماعة. I'm not sure if anyone has joined yet. I guess there's a bit of a lag. Just let me know in the chat if you can see me or hear me, and if I need to make the volume higher or something. This is the first time for me to do a live stream. I'll be doing this in English because I'm not sure if everyone joining today understands Arabic. So this might be a little bit difficult. I haven't done such a long video before in English. So yeah, I might forget a word or two while I'm talking, just bear with me. So let's wait like a minute or two for people to join if anyone else is joining. Just let me know if you cannot hear me well. And I do apologize, most of the time I'll be looking up because the setup I have is the camera is just below the screen, so I'll be always looking like this way while the camera is this way, so I hope it doesn't feel weird for you. Yeah. So I can see a couple of people have joined already. Hello Hassan, hello Abdul Rahman, Abdul Hafiz, Abdul Rahman Awad, Mark, Hisham, and Lubna, and Mustafa as well. Okay, so let's dive right into it. So basically this set of sessions will be talking about the how to build a 12-factor app. And I'll go in a couple of minutes into the details about what constitutes into a 12-factor app. But basically there are like a set of check boxes that you need to check before you put your app into production to make sure that it's easy to debug and fix, it's resilient to errors, and basically it's you can rely on it. You don't have to worry a lot about like its setup and how it's running and so on. So it's cool that the guys who built like these 12 factors did this, because now it's easy to just look through them and know what exactly is missing from your app, and make sure that you fit it in and fix it right away so that your app becomes more compliant to these 12 factors. So if I go quickly here into the slides I have prepared, and by the way, you can take a look at the slides at any time. They're available in the link. You'll find it like at the bottom of the video. It's for you guys to be able to follow up with me while I'm talking here. I'm not sure how long the lag is, so I'll usually try to wait for a couple of seconds whenever I finish a certain section of these slides to make sure that if anyone has questions, they get the time to say them, and like on the chat, and for me to read it and be able to reply. So yeah, the link, it's https://ramino-12factor. You can go to that link to follow up with the slides, and later on I'll share with you like a link for the repo that we'll be using throughout the sessions. Maybe I can show you this here. Yeah. So yeah, this is the link to the slides. Let me copy that into the chat so that everyone can easily go to it instead of having to type it in. And later on you'll see that this link here is the link to the repo. Okay, Hassan, yeah, well, the volume might be up. I'll try to lower my voice a bit. Hopefully it's better now. The thing is, I didn't want for the voice to be too low, because that was usually the case whenever I recorded videos on my laptop here. So that's why I raised it a bit up, but it's up to 100. It's not more than that. So if that's too uncomfortable for you, let me know in the chat, and I'll try to lower it a bit. Anyway, so let's get started here. Just let me know, guys, if you have any problems accessing the slides. So 12-factor app. What is a 12-factor app? Basically, as I said, a set of a methodology that is followed in order to be able to build software and basically like service applications that provide services. There are a set of best practices, so there are like advisements for you to either use or not. Like the creators of this list try to make your life a little bit easier, but of course at the end it's up to you to decide whether these set of factors are fit for your app and like your working environment and your team and company or not, and either to follow them or not. So as I said, they're just a set of best practices that are designed to enable applications to be built with portability and resilience when deployed. And this list was built by Heroku back in 2011, and there's actually a website where you can check out to see like the details of each of these factors in the link at the end here, like 12factor.net. So a brief introduction, like the 12-factor apps, they try as much as possible to use abstraction to describe how best to set up like your app and automate it so as to minimize the time and cost you use to develop the app. It also allows the app to have like some sort of a contract that enables it to easily integrate in its surroundings, those surroundings being the operating system it's being running on, or like the deployment environment or production environment that it's being deployed to, so that the app becomes more portable. You can just throw it anywhere and it would work as expected. It's suitable basically because it's portable to deploy it into like the modern cloud platforms like the Google Cloud Platform or AWS or Microsoft Azure or whatever of these newly popping up cloud platforms, where you can just like put your app together and follow a certain set of rules and then throw it to whatever cloud platform of these, and then it will be able to handle it because it knows how to handle it if it follows like the basic rules that we are going to talk about during these sessions. And this allows you to not to have to worry about what kind of infrastructure is actually being used to handle the deployment of your apps. You can just wrap it up, throw it to these cloud platforms, and just sit back and watch your apps coming live without worrying about the infrastructure or anything. Like the 12 factors also try as much as possible to minimize the difference or the divergence between your developer, your local development environment and the production environment. It also helps to enable what we are going to discuss in a couple of minutes, the continuous deployment for your apps. And it also allows you to be able to easily scale up your apps without having to worry about any tools or architectures or like anything else. Like lower the thing that you have to worry about whenever you need to scale up your apps. So yeah, a quick disclaimer here. The sessions will be going a bit from a basic level up to like an intermediate level. So today's session might seem a little bit obvious for some of you guys if you come from a background of software engineering or you've been working in a software like software house. But the reason why I wanted to start from this level here is that some people who asked me to do these kind of sessions had almost no background about how even to think about deploying your apps. So this is why I decided to start from scratch, explain as much as possible what's going on, but I promise you don't get bored so quickly. Starting from the next session or so, things will become more interesting. I'll have more demos and more practical stuff to do, so just bear with me throughout this session. This is like a test trial or like a pilot for the set of sessions that I'm going to do. to make sure that this is what the people are expecting and to get some feedback about what to do next. So even if you are an advanced guy, just help me make these sessions better for the rest of us, okay? Thanks. So the motivation behind building this list, as I mentioned, is to provide some sort of systematic way to build apps and make them more resilient. Also to provide a set of shared vocabulary, and I like using this a lot because it like breaks or lowers the barriers between developers whenever they're talking about applications. They don't have to know about like the programming language used in applications, or like what kind of infrastructure is being used, as long as they use this common vocabulary to talk about their apps. And this makes it easier for teams with different like technological stacks to integrate easily and to go up and running like quickly without having to worry about adjusting to each other's like backgrounds. They also offer like a set of conceptual solutions to some of the problems that have popped up like throughout the previous decades when it comes to deployment of apps. And as I said, they're just best practices, so you don't have to follow them to the letter. They're just like some sort of a guide in case you have no idea what to do, and so you can just follow them. But if you know what you're doing, you can just ignore these, or maybe pick up from them what makes sense to you. Yeah, so it's called the 12-factor app because it needs to follow like 12 factors. And we'll be going through these 12 factors through the 6 sessions that I'll be conducting. Today I'll be talking mainly about the first factor, Codebase. As I mentioned, it's a bit basic talking about it if you have already dealt with like Git or any source control or versioning systems. But as I said again, it's to make sure that everyone is on the same level here. So yeah, first one is Codebase, second is Dependencies, third is config, backing services, and I mean you guys can read. And I won't be going through them like in order. I'll be like combining similar factors together in the same sessions because in my point of view it makes more sense to explain them or practice them together in order to understand exactly what they mean and how they differ from each other. So yeah, first one is Codebase, and basically like the motto for it is that one code base tagged in revision control and many deploys. So this is like the slogan for this first factor here. So what is a code base? As I mentioned, we need to have like a shared or a common vocabulary, and that's why like whenever I start talking about a new factor, you'll find me basically listing a set of vocabulary that are common to this factor. For the first one here, Codebase, we need to understand what Codebase means, what a source code repository means, and what a version control system means. So in software development, a Codebase basically refers to like a bunch of code files, like a source code files that is built or written to build like a certain software system or app. And a Codebase includes only human written code source files, like source code files. So if you have like binaries or I don't know, tools or something that are related to your project or app, you should not include them in your repo. You should like include whatever is written by humans as like source code for business, for your app's logic or business logic or whatever. But when it comes to tools, maybe you include like a README file or something that tells exactly how to get a handle on these tools. But you should not, as much as possible, include them unless it's like extremely necessary. And like, but what I mean by binary library files is like the output of running the tools. Like if your code needs to be compiled in order to be able to run it, this compiled like binary file that gets created whenever you build your code, this should not be a part of your code base. Because most of the time these kind of files are extremely huge and they differ from one operating system to the other. So they'll be creating like a load on your code base, increasing its space without the need of having them there. Because basically, if you run the code, you will be able to regenerate them. So there's no need to include them in the first place. You can also include like configurations or property files which are needed for like frameworks, for example, that you're using to operate as expected. And those are okay to include in your files, as long as they do not include secrets or anything sensitive. And I'll be talking about that like when it comes to another factor, but for now just know that it's okay to include some configuration files in your code, like in your code base. So the code base is basically stored in a source control repository, or for short, a repo, that belongs to a revision control system. And we'll be talking about what revision control system means in a couple of seconds. It's a place where, as I said, a large amount of code is being kept, either publicly or privately. And I guess you already have heard about some of the services over there that provide this kind of functionality for like revision control systems. And what I mean by public or private is that even companies that worry about their code not being exposed to the outside world can use these kind of services to store their code safely without worrying about it leaking outside. So this is what I mean here by privately keeping a source code repo. The repos are basically used for backups or versioning, and what I mean by versioning here is that you can feel free to work or do whatever changes you find needed to your code base without worrying about losing all files or all changes, because this is how source control works, in that it keeps versions of your source code. So whenever you make new changes, the old ones are still there. You don't have to worry about them. You can actually just roll back to one of them in case you need to go back and check something that you have deleted before. It's also really nice to have this kind of history, because now if multiple people are working on the same code base, you will know exactly which one did what, and then you can help like integrate the different parts of the system written by the different developers. And most of the cases, like the system, like the services, the revision control services that do that aid in this process, like in resolving the conflicts in case any happen whenever like two people from your team are merging their code together in the same app. So what used to happen before, like using USB flash drives, and then the worry about having to dedicate like a certain period of time to integrate the different parts of the code into just one code base, you don't have to worry about that anymore, because the like the revision control system will do that for you automatically without messing anything up, like in 90% of the cases. So as I mentioned during when I was talking, like that the most known system, like for me at least, is Git, Git, which is like just a brand name for revision control systems. And there are a couple of other like tools like Subversion and Mercurial that are also able to do revision control, like source code revision control. And these tools are basically most of the time used to build like open source projects. Yeah, so code bases can be used for whatever kind of apps, that being like small apps, medium apps, or even large apps. And it's actually depending on the developers whether to have their whole app in just one repo or dividing the code base into like multiple repos. But there's like a pro and con for each side of things. And when everything is just contained in one repo, that is called a monolith repo, or a monolithic code base. And it typically, as I mentioned, contains every single thing that needs to be there for your app to run. And the advantages of having such like a monolithic code base is basically because it simplifies integration. So you don't have to worry about bringing the code from different repos all around the internet just to make sure that your code works. You have everything in one place. You just hit hopefully one command and then everything runs. But the disadvantage on the other side is that, like, imagine this example or scenario with me. If you are new to a team and you get to work on their app, and then on the first day you need to download the source code for the whole app, even though you're going to work on like a small portion of it, this is a bit like it. You will get lost, definitely. Like, going through all of the source code files just to find the place where you need to do the adjustment that you have to do is a bit tiresome. So this is one of the downfalls of using like a monolith app, is that everything is there. You cannot directly go to a certain place without having to look around for some time. And this, as expected, will introduce what we call the technical debt. And what I mean by technical debt is that there are basically like mistakes that you do intentionally while you're coding or developing an app, because you need to get things up and running. And these mistakes you need to somehow resolve in the future. And the thing is, these mistakes keep on accumulating, so this technical debt keeps on accumulating until it's sometimes, most of the cases, a huge thing that might affect like the development speed or process of your app. So when you have a large code base like that, a lot of people are working on it. If it's not maintained like on a high level, this might lead to a lot of these mistakes being made, and then like a huge technical debt being there on your shoulders. Okay, so for the next vocabulary I would like to use here is the environment. So what is an environment? So an environment in a software deployment is basically a system where your program or app is being executed. And usually there are like at least two kind of environments, like a development environment, which is basically your local machine, your local laptop that you're working on, and the production environment where the live application sits and where your like end users get access to it and so on. So this is like the minimum case that people have, like a development environment and the production environment. But most of the time it's not just about these two environments. There are like several stages or environments in between, like, I don't know, testing and staging and whatever. And usually the deployment of an app goes through these stages until it reaches like the last one or the last environment, just to make sure that throughout this stages nothing happens that is not expected that would then propagate until the production environment. So yeah, as I said, this structured release management process allows for phased deployments or rollout, testing, and rollback in case there are like any problems. So these are like an example of what kind of environments you can have and like what each one of them is being used for. And like the first one is the local or development one, the last one is the production, and there can be as many as you like stages in between to make sure that your code propagates like or like is being released in the best scenario that fits your needs. So I won't go through like the details of this. You can just read them or check them out on the link I shared with you in the beginning. But yeah, I guess their names are quite informative about what kind of like what state of your app is going to be running on each of them. Yeah, so moving on, I'll be talking about Git, which is basically the like the tool used to source control. And yeah, it's a free and open source version control system that you can download and run on your machine right away. It's used for source code management, and it's considered to be a distributed version control system that is aimed at speed, integrity, and support for nonlinear workflows. Blah blah blah. Okay, just some stuff from Wikipedia here. But what I want to say about it is that it makes your life easier if you know how to use it well. So these are some of the characteristics of Git. Basically, it allows for rapid branching and merging. I'll be talking about branching in a couple of seconds. It gives you tools to visualize like the history for your source code, and this is, believe me, really important when it comes to building like large apps and having like a long history of it. It differs from other tools in that it allows you to keep a local copy of the code on your machine, like the full thing, the full development history on your machine. And it allows you to work like totally offline until you're sure you're done with your version of the code, and then push it to whatever source control system that you use. It's fast and scalable, and because basically it can handle a lot of code, a lot of files. It can handle a lot of team members, so it can be used whether you're building like a small app or like a huge one. And it's just like a set of tools that are packed together for you to use. So it needs like a bit of a learning curve to be able to understand how to use it. But once you get a command of it, it will make your life easier. Yeah, it allows you to do what I will be mentioning later on, which is called merging. And this is basically if a lot of people on your team are working that need to merge their code together, it does that for you. It does its best like to do it. Sometimes it fails to do that, and then you will have to intervene manually. And this is what we call like resolving conflicts. In case like two team members were working on the same exact file or line in the file, then the system gets a little bit confused in which version of these two members code to include in the final like repo. It has algorithms to try to resolve it, but as I mentioned, it does like some of the time it does not work, or just to be safe it tells you that you need to do it manually. And it also takes cares, like Git also takes cares of your repo, making sure that it like if like there are a lot of commits being made or a lot of files being added, there are garbage collected. And what I mean by that is that it tries to be smart about what kind of files or to keep in the history and so on. But yeah, it doesn't delete anything. It just tries to be smart about it. So instead of saving multiple full versions of the file, it just like saves changes to make it easier for you to then download the repo without having to worry about its space or something. Yeah, so this is a little bit technical about how it internally deals with the files, but yeah, you can read it if you want, but we don't have to worry about it here. Okay, so the next thing I want to talk about is this plugin that can be added to Git. So basically Git is like a command line tool that you can use, as I mentioned. It's a set of tools, and this Git flow is like a plugin that you can install to Git that allows you to like move your code around in like an organized manner that tries to match the environments, the development, like the deployment environments that you have. And what I mean by that is that whenever you need to make changes to the code, Git flow tells you what is the process to do that. And this is mainly very useful when it comes to like process management, as in, or what is it called, like approval management, when you need to approve changes to the code before merging them into like the production code. So Git flow allows you to do that in a systematic way, and most of the services that provide source control adapt to this Git flow model to make sure that the required process is being applied. So it just has like it just provides some naming to what can be done on the repo. As I said, just common vocabulary, and you can check out the link at the bottom here to read more about how it works, but I'll briefly go through it now. Git flow mainly works with branches, and what I mean with branches is like in a single code repo, you like initially have this main branch or master branch, which is basically the code that is deployed to production. And then you would have this like a copy. What I mean by branch is just a copy of your code. So you have another copy going in parallel with master that is called develop, and this other copy is mainly used to develop features or like new features. And whenever a new feature is done and tested, the develop branch gets merged into the master branch, so that changes made in the develop branch are added to the master branch. And as I said, they are just copies, so whatever you do in one branch does not affect the other until you explicitly merge them. And Git flow says that you need to have at least two branches here, like the master branch for production and the develop branch. So yeah, the master branch stores the official release history, and the develop serves as like an integration branch for features where new features are being developed. And this is how it basically looks like. So you have this like in blue here, the master branch. I'm not sure if you guys can see my cursor or not, but I'll try to describe what I'm looking at or pointing at for you guys to follow. So this blue or light blue line here is the master branch, or like the production branch. It does not have so many changes. Like each circle on this line means there has been some change that was added to the code in this branch. So as you can see here, it doesn't have a lot of changes. There are major changes, but they're not a lot. But on the other side, okay, thanks, Mark. So on the other side, this purple line here is for the development branch, which shows like the active features that are being developed. And you can see that there are more changes compared to those on the master branch. And yeah, so whenever new features are made, these features can then be merged into the master to deploy them, if I may say. So the other type of branches that can be in GitFlow, or that are suggested by GitFlow to use, are what we call the supporting branches. And those are branches that aid in parallel development. So basically to enable your team members to work in parallel without having to overstep on each other's toes. And usually these branches have a limited lifetime. That means that they are being spun off to do a certain thing, and when they are done with doing that thing, they should be deleted and merged into one of the main branches that I mentioned before. There are three types of these supporting branches. You can have a feature branch, a release branch, or a hotfix branch, and I'll be talking about each one of them briefly, like in a moment. And each of these, as I said, serves a certain or a specific purpose and has a set of rules around it that define exactly how they work and how they should be terminated and so on. Feature branches, which are like the most commonly used branches, are basically like a copy of code that is being spun off the develop branch, and they are used to implement new features. So whenever you're creating a feature branch, you're just taking a copy of the develop branch, doing whatever changes you need to do in this copy to implement like the new features, and then once you're done, you should delete this branch and merge its changes into the develop branch. And you can see this visually here. So we can see the two lines, the blue and purple lines, as from before. And what's new here is the green lines. So you can see there are two green lines here, which means mainly that like two of your team members are working on two new features in parallel. And each of these branches has its own changes, and whenever you're done with a branch, like the first green line here, you should merge it back into the develop branch. So this feature here, like the first green line is a completed feature that was developed till the end, while the other green line is a feature that is being developed, or it's like a work in progress. So once this other one is done, it should be merged also back into the develop branch. Okay, the second type of supporting branches is the release branch, and basically these are branches that are used to prepare a copy of the code that is going to go into production. And what I mean by that is that they're like intermediate branches that take whatever code is in development and do some modifications on it, like adding some documentations or last minute bug fixes and so on, and then these branches are merged into the master branch. And one very important thing that needs to be followed here is like one of the rules about release branches is that they have to be tagged. And what I mean by tagged, it's like a feature of source control where you just attach a flag to this branch when it's being merged into master, saying that okay, this is version 2 or version 3 of my app. And this makes it easier to like know exactly when different major releases were made in your app. It can also allow to add like change logs to make it easier for your users to follow up on whatever new changes or features that were added to your application. So yeah, it basically helps you know the major history of your app. And these release branches, because they include changes like, as I mentioned, the documentation bug fixes, should be merged in the develop branch as well. Okay, so that no source code is lost, or so that there's no difference between the developer master branch. So yeah, you can see that visually here. So this is the same diagram from before, but we see this new teal. I hope that's the correct color. This teal line here it's like a release branch. It takes it gets spun off from the develop branch. It adds some changes, as I mentioned, like documentation and fixes. Then it gets merged into the master branch. A version is added, as we can see in the square blue boxes at the top, and then it's also merged into the develop branch. Cool. Third one is hotfixes, which is basically a branch that is spun off to do a quick fix for some bug that is found on production. So because it's fixing something in production, it differs from the other support branches in that it's being forked or spun off from master, not from develop like the other ones. So you get a copy of the master branch, you do the quick fix as soon as possible, because most of the time they're like critical, there are fixes for critical bugs in production that you don't want your users to have or work with. And then when you're done, you should merge this into both master and develop, similar to what happens to the release branch. And you can see this from here. So we have the same diagram from before, but the extra part is this red line here, which is for hotfixes. It comes off from the master branch, you do the changes in it, and then gets merged back into the master branch and as also into the develop branch. Yeah, so I've been talking non-stop for a long period now. I guess I'll pause for like 10 seconds in case any one of you guys have a question. I guess because of the lag, you weren't able to ask questions, if any, right away. So if you still remember these questions, if you have them, just let me know now in the chat. If not, just let me know so that I can proceed. Okay, I don't know how long the lag is. I guess it's around like 10 seconds or something. Yeah, my internet is not at its best right away. I tried to like upgrade it before starting this session, but yeah, I guess T data has a branch over here, not to talk about politics. Yeah, but yeah, we're not the only ones in Egypt worrying about like internet. Okay, Hassan, yeah, so, well, I'm a big fan of squashing if we were talking about it, because it keeps the history of our bench more concise, but this is a little bit advanced, so maybe we can discuss it later on. But basically what Hassan is talking about here is like different strategies used to be able to merge code from different branches together. So what I'm talking about here basically is merging, where just whatever new changes that were made to a certain branch are added to the history of the other branch. What Hassan is talking about is rebasing, which is a different form of adding the changes to the main branch. And like the third type is squashing, which is basically compacting all of the changes into just one change and then adding this change as an extra level of history in the main branch. So yeah, this is quickly the difference between this, the three strategies of merging branch, or like, yeah, merging is the English word for it, merging branches together. But anyway, that's like a little bit advanced for now. Yeah, so you just need to worry about like the concept of adding the changes from one branch to the other, as I mentioned. Okay, so we've been talking about Git as a tool that you can use locally, but there are services over there that implement the Git protocol for you to be able to push or send your code or upload your code to them, so that it can be easily shared with your other team members. And one of these services is GitHub. It's a web-based hosting service for version control using Git, and like it offers all of the different features that Git provide, as well as adding its own features to help make like the development process easier and more smooth for you, and to also allow you to implement whatever approval process that you have without having to do it like on a separate system or something. There are some other services over there that compete with what GitHub does, those being GitLab and Bitbucket. Both of them mainly use Git, but they also offer, similar to GitHub, like other protocols to use, like Subversion and Mercurial. What's cool about GitLab is that you can deploy it yourself on your own servers, and then you'll make sure that you're not using their services or exposing or not exposing, but putting your files on someone else's disk. You can deploy it on your own servers, but then you'll have to worry about the trouble of maintaining this deployment. Bitbucket is a service provided by this company called Jira, which I guess if you're working in a big software company, you would hear about it a lot. To be honest, like in my own opinion, I'm not a big fan of Bitbucket. I feel that it's lagging behind the other two services, but I mean, when you have to work in a big company, you really don't have like a say in what to use or what not to use. But anyway, aside from that, basically these three services offer like the extra features that I mentioned that have to do with like the approval process, and I'll show you like an example of how to use this like in a minute. So moving on to the next part here is pipelines. So since we spoke about the different branches for the code and the different stages of the deployment, we need to talk about pipelines. And pipelines are basically the way to move from one stage to the other, but like from one environment to the other, but in an automated manner, not having to do it manually. And pipelines are mainly defined are used to define what are the steps needed to move your code or your app from one environment to the other. Those steps can include like running some tests, publishing some changelog, integrating with other services, or even like scaling up your app, or anything actually that comes to your mind when it comes to deploying an app. So they are basically just a set, like a group of jobs that are divided into stages. The stages run like in sequence. So once the stage is done, the next stage is invoked, and each stage can contain multiple jobs that are being run in parallel. And as I said, pipelines are mainly used for CI, which is short for continuous integration, and CD, which is short for continuous development. And I'll be giving a small hint about the difference between them like in a minute. So this is an example of a pipeline. We can see that it is formed of three stages here. So the first stage is just pulling the code from different repos. The second stage is building the code and running tests. This could be like unit tests or integration tests or both of them. And the third stage is deploying the app to like a staging environment and a production environment in parallel. So as I mentioned, pipelines are used for CI and CD, and continuous integration is mainly about like the best practices that developers need to follow in order to be able to integrate the code into a shared repo, and making sure that these changes do not break whatever old code that was there. So this is the part where integrating code from different repos happens, where testing happens, and so on, just to make sure that your app is ready for production without having any issues in it. The second part is continuous delivery, which is basically taking this new version of your app and putting it in production for your users to be able to access it, basically releasing your app. Most of the time, companies implement only CI because they are too afraid to automate like the delivery or the deployment or automatic deployment of their apps. But like the 12 factors here encourage people to have both, because if you follow the process, basically, there's a huge chance that nothing will go wrong during like the pipeline while it's running. So it's always better to always deploy your apps as soon as you have new features, just to be able to get fast feedback from your users. So there's this thing we use that is deliver frequently, like this term here. Instead of having to wait months, for example, to deploy your code to your users, in order to follow like the agile methodology, you need to keep on quickly deploying or delivering this code to your users so that you get instant or fast feedback from them, and then reiterate on whatever feedback they have without breaking a lot or having to worry about old code that has not been touched for a long time. So there are a lot of types of CI pipelines. The basic one is just like a single stage CI, where it builds, tests, and deploys your app in just one step. You can divide these into different stages just to make them like visually easier to the eye. So you can build in one stage, test in another, push in the third. And as long as like the job for building or testing or push is not that complicated, Sometimes any of these two types, like one or two, are okay for your app. But when you need more stuff to be done, like for example, if you have multiple things to be tested and you need to implement parallel testing, then type 3 comes in handy, because then you can build in a stage, then run the parallel tests all together, instead of having to run them in parallel. In case your test suite or something takes a long time to run, you can do this in parallel and wait until all of the jobs in the test stage are done, and then deploy or push the app to production. And the fourth stage is usually used for like having different flows depending on the like statuses or the successfulness of the different stages. So in this case here, like in the test stage, if everything worked correctly and all the tests passed, then the app will be deployed. Otherwise, maybe an email will be sent to the admin to tell him that someone messed up big time, or maybe just notify that there's a problem with the code, or something that needs to be fixed. Sometimes this fail scenario actually is really useful, because instead of, like, you want to have automated delivery, like you want to have CD, but you want to be safe as well. So these kind of forked stages help in that, because your app is only deployed when everything is tested and working as expected. Otherwise, it will just remain at the old version that is being currently served, and then you will be notified that there's a problem with the new build, and then you get a chance to fix it before redeploying it. So this is an example of a CD. Usually what happens is that, like for the pipelines to align with the branching model proposed by Gitflow, what happens is that whenever you create a new branch, this branch is built and tested in its own environment. If you're like talking about the perfect setup here, this is not always applied, but sometimes I have seen that in many companies it happens, where you don't have just the main environments that I spoke about before. You also have like sub environments that are made for each feature that is being developed. So this is parallel to the branching model of the Gitflow, where the test branch, the feature branch is also being built and tested before it's merged into the master or the develop branch. And this is really nice, because then each developer can have his own or her own app version of the app deployed, which he or she can test and play around with before submitting it for approval to be merged into the develop or master branch. And usually this submission or this merge is done using like what we call a merge request or a pull request, which is like a feature provided by the services I spoke about, like GitHub and Gitflow and Bitbucket, to add like a level between merging the branches together. So usually there's a request that's being made where it shows like the changes that were made in a feature branch and how they differ from the branch this feature branch is going to be merged into. And then like your other team members can review these codes, this changes, and give you comments on them, so that you can reiterate on them if in case something wrong is being done. And once everything is good to go, then this request is approved. And once it's approved, the changes you made in the feature branch you're working on get merged into the final branch, that being the developer or the master. So this is what it means here by creating an MR or a merge request. It's also named as a pull request or a PR on other systems. Then once this is merged into master, its own pipeline is also run, where it's get built and tested and deployed, for example, to the staging environment. And once like this master branch or whatever branch is ready for production, then it gets tagged and deployed to production in its own pipeline. Okay, so this was the last slide for today. I hope it was useful for you. I'll give you now like a quick example on how the different branches work, like in a real life example, and maybe show you a couple of tools that I use to make my life easier. So let me move over here quickly. There is this repo that I was working on before. It has nothing to do with the sessions. I just found it as a good example to show how the branching model works. And so you can actually find it on my GitHub account here. If I can quickly navigate to it. Yeah, that one here. So it was an old repo that I built for like an interview that I was doing. Anyway, it's basically like a website to handle vehicle production, a vehicle production factory. And what I wanted to show you is, so if I navigate quickly to it here, is how the branches look like. So I'm using Git in it. We can hit Git branch, and then we can see the different branches that we have. We have the master branch, which is like what corresponds to the production environment. In my case here, the development branch, which corresponds to the development environment. I have and like this hotfix branch, which is for something that happened in production that I needed to fix. And there's a tool that I like to use, Git K, which basically shows the visualization of like the history of the source code of my app. So you can see here that this orange line here on the left corresponds to the master branch. Okay. And the one on the right here, this light green one, is the development branch, and each point on it, like each circle, each blue circle on it, corresponds to a change that was made in like a feature branch and merged back into develop. So because each change would just one change only was made in the feature branch, it shows up here as one circle. But for example, in this one here, you can see that in the feature branch, two set of changes were made, and that's why it shows it like a spin-off from the develop branch and then a merge back into it. And as you can see over here, like at the top here, the develop branch got merged into a release branch, and then this release branch was merged into the master, and this and tagged as well here like version 0.1, as you can see. And this means that the code was now ready to go into production, and then it was so it was merged like into a new branch here. And the hotfix also is represented over here, where the code got spun off from like this dark red line, spun off from master, then the change was made, and then this was merged back into master as well as into develop. Okay, so maybe what I'm missing here is merging the release branch back into develop, but I guess no major changes were made, that's why I didn't do it. But yeah, this is basically how it looks like in real life. So this is also here like another release that was done, version 0.2, which is merging from develop to master using a release branch. Yeah, as you can see here. So yeah, this is basically how your repo should look like. And to do that, as I mentioned, you can just use the git command line. So you can switch between branches using the checkout command. Yeah, like whenever you provide it with a branch name, it switched to it. So for example, develop, it will show you now that you are on the develop branch. I have this like helper tool here that shows me what is the directory I'm currently working on and what branch I'm standing in right now. So again, this checkout command is used to show you like to switch between branches. If you need to create a new branch, you use the same command, but then you give it this -b flag. Okay, so for example, I'll be creating a new feature here. Let's call it fix readme. And then there's like a convention about what exactly to call the branches. Usually I go with the kebab case here, where I just call feature / and then whatever name I give to the branch, I do it in a kebab case. And what this command does is that it creates a copy of the develop branch into this feature / fix readme branch. So if I go to the readme here, oh, I don't have it open. Okay, so let me move this back here. Okay, so if I open up the README file, I can see this is the current version of it that I have. Maybe I want to add like a new section to it. Let's call it about me. So I can see this is the README that is displayed over here. So if I add about me here, you can know more about me by visiting my website. Just let me add like a quick thing here. Okay, so now I made my change. I saved my file. If I use git status, this shows me what exactly was changed. So here we can see that the README file was modified. If we use get diff, this shows me what exactly was changed inside of the file. So I can see in green here that this section was added to the end of the file. What I need to do now to like submit my code change to like GitHub to upload it is to first create a new commit, and this is like the notation used by Git to like group a bunch of changes together. So to create a commit, first I need to tell Git which files I want to include in this commit, and this I do it using the git add command. So I want to add the readme file, and if I do git status again, you'll see that now this is in green, not in red as it was before. Then I need to give this commit a message, like a descriptive message that says what exactly was done. And to do that, I do git commit. So now I'm creating the commit with the staged file and giving it a message like update readme with about me section. Okay. Once I do that, the commit is created, and I can check that it was created successfully by running this git log command. By the way, is the code visible for you guys? Like, is the font large enough? The code or whatever commands I'm writing in the terminal. I've tried to zoom them in as much as possible so that they are still look okay for me over here and look okay for you guys on the internet. Okay, so going back to it, git log can be used to see what commits were made here. So we can see commits from before, like this goes back to 2018, and this is the last commit that we just did here. And to know more about what happened in this commit, we can use the git show command and then pass it this ID for the commit that I copied from git log, and in it we can see exactly what was done. So this is the message of the commit and the changes that were made. And to upload this commit to GitHub, we just do git push origin feature fix readme. And once I do that, just give it some time here, and I go over GitHub here, I do a refresh. You can see it already picked up that a new branch was created, and if I check it out, check the commits, we can see this new commit created over here. And what I wanted to show you guys is that if we switch to the develop branch, the new commit is not there, and that is what I meant by that each branch is its own copy of the code. So this copy does not affect or changes to this copy do not affect the other branches. So what usually happens here is that once we have a new branch, we should create what I mentioned before, which is the pull request. And the pull request is just like a request to merge code from a supporting branch to one of the main branches, that being the develop or the master branches. And you can see GitHub here makes our life easier by just popping up this green button here, which when we click on it, it says that we're now trying to compare this feature branch fix readme with the develop branch, because we should always merge our supporting branches unless otherwise specified. We should merge it into the develop branch. It gives you at the bottom here like what are the changes that were made so that you can review them one last time, and then when you create the pull request, it's actually saved to the website, and then on the right side here you can add some reviewers, like some of your team members, to check it. You can assign it to yourself in case you want to like keep track of what you're working on, add some labels and projects and so on. Those are like project management stuff that can be managed by the project manager of the team. And then once this code is approved, like you can check, your peers can check the commits over here and what exactly was changed. Maybe type in some comments. So this looks good. Okay, and once everything is okay to go, we can then merge the pull request over here. And what Hassan mentioned before, like the different strategies are over here. Like you can merge the commit, squash and merge it, or release and merge it. And there's a brief description of how these three strategies differ from each other. But yeah, it's not really the topic of our session today. So once I click merge pull request, it tells me like which user to use, and then confirm. And you can see now that it got merged. You can either delete this supporting branch or not. For me personally, I prefer to delete it, just to keep the list of branches to a minimum. And what merging did here is that it added the changes that we did to the develop branch. So if you go to the develop branch here, you can see now it has 29 commits, and it has like the commit we just created. So if we navigate to the home page of this repo here, go all the way down, we can see that the About Me section has now been added. Okay, so the same thing can also be used with when merging from the develop branch to the master branch. So I guess I have a master branch over here. Let me check quickly. You can just create a new pull request here and tell it that we need to merge the develop branch to the master branch. And then it shows what changes exactly were done between these two branches, and you can create a pull request and merge it all from here. Yeah. Okay, so I guess that wraps up what I had to say for this session. Do any of you guys have any questions? Oh, okay. I guess no questions here. Okay. Okay, so I really appreciate it, guys, if you give me like feedback on how the session went, if you need anything changed or added, and let me know, guys, if you want me to continue doing these sessions. So the next session will be talking about the other factors that we have from the 12 factors. Hopefully my internet will be better in the next sessions. I'm not really sure, but let's hope. Yeah, and I'll be posting soon if you guys want me to continue with this, like what kind of prerequisites you need to have before moving on to the next session, so that you can actually try things out with me right away. I'll be posting this later on for you guys to follow. So we have a question here from Lubna. I just want to get your advice. I have basic knowledge of Git. Sure, if you have any questions, feel free to shoot them. And not just now, like, I mean, if you have questions even after I end the stream, just feel free to add them as comments to the video, and I'll just reply to them right away, or just contact me on like any of the social media websites. Do I have any idea about how to gain more knowledge and experience? Well, my advice for you, Lubna, is to go through the resources that I mentioned, like the 12-factor app and the Git flow model here. But the most experience that you gain is from actually working on a project. So you need to either start working using this in your company where you do your day-to-day development, or even do it on like a side project in order for you to gain knowledge about it. It might be a little bit difficult to use like command line tools similar to this git command here, and there are some tools like git that I showed you a couple of minutes ago that helps you deal with the repo without using the command line. There's also this tool called source tree that I usually use, which basically gives like a similar overview to what gitk does of how your branches look like. It makes it easier for you to navigate through the different commits, check out what files were changed. So here we can see like the last commit that we did and what was changed, when it was changed, who did the change, and everything about it. You can switch between the different branches here. I guess you can also like integrate this with GitHub and even do pull requests from within this app. So this is a way for you to get your hands on really fast on Git. But as I mentioned, to gain experience, you need to work with it on a day-to-day basis. I mean, you can read about it, but for me at least, like it's a personal opinion, I prefer learning by practice, not by reading. And this usually works for me whenever I'm working with like software tools. Just reading about it doesn't give me the full picture. So practicing it, getting my hands dirty and diving right into it helps give me the most experience. So I hope this answered your question. Okay, so if there are no more questions, let me guys end this stream here. Thank you very much for staying until the end. At least whoever of you who stayed, and yeah, I'm waiting for your feedback if you need anything to be changed or added before the next session. Just follow my updates on Facebook and Instagram. I'll be telling you about when the second session will take place, hopefully soon, maybe next Saturday. Anyway, I'll let you know, and if you have any questions or comments, just let me know about them. And again, thanks for watching, and see you next time.